test results can get translated into designs because oftentimes throughout testing, we find out things we didn't originally know about that container based on the style of testing. We may have tested it in too robust of a manner to say, okay, this container is not suitable for, let's say, a battery testing. This container is great for what that customer asked for, but we said maybe it could be for a bigger battery. And we find out, well, if we want to put anything bigger in that, we need to upgrade the design. Maybe we need to add channels for gases to flow, maybe a pressure release, or something where that it can't become a pressure receptacle. That's the kind of things we find out. Or if we're doing a drop test, they may say our battery weighs 800 pounds now, but in the future, we'd like to rate this for 2,000 pounds. So we're going to go ahead and drop it at 10% over that highest number and say, well, this initial design is not future-proof. Let's go ahead and tell the customer that and go back to the drawing board. Maybe we need to add some stiffeners or some ball corners and make that thing more robust. It can handle any needs of the customer in the future. In some instances, test results can affect the manufacturing process. If we determine that we need, for example, on a project we did recently, we needed something to cushion the blow in a drop test because a very sensitive piece of equipment was being shipped in the container. And oftentimes we may not make that particular part. So that will change the manufacturing process, where we've got to decide in the production flow when we order those other parts, when we assemble that, and how we change our production flow in order to meet the dock date for the customer. When we make test plans for just our lithium-ion customers, we have to first determine which government body or regulatory body is going to allow them to get what they call a pass and put their product to market. That will let us know which standard they have to pass. And they'll have to pass it at a NERDL lab, nationally recognized test lab. But they come here first, we do all the same things. And one benefit they get from us they don't get from those labs is we'll tell them how to fix it. So we'll tell them this is the standard you want to pass, and we'll scale it down. So rather than testing the entire battery pack as a whole that may have, let's say, 70 cells in it, we'll test a single cell and see how volatile it is and see if they need to update their design or change the spacing between cells to get what would be considered a pass. And then we'll do it at a modular level. Instead of all 70, maybe those 70 are in 7 arrangements of 10. We'll test the 10 pack and see how that behaves. And then we'll scale it up from there. So we're able to help them in their design process just by starting at the lowest level. And then that test plan pretty much develops itself from there. The UN, for example, some of the subcommittees there have regulations in the 49 CFR, or you've got UI or UL, Underwriter Laboratories. They will put out their 9540A, and it just depends what type of product it is, how it's allowed to go to market, and where it's installed. If it's installed on a residential building, let's say solar, for example. There's battery packs in solar, but there's different regulations they have to pass if they're in a warehouse or if they're on your house, you're on your home. So it's all determined by some government or regulatory body. If they get a failure, we will do an autopsy on it, where other labs, they'll just give you your equipment back and say, hey, you failed. We'll open it up and inspect everything and tell them where it failed, why it failed, and how to improve it so that it won't fail in the future. Now, maybe not on the next iteration, but it's several down the road. And the length of time it takes, it's based on two things. How well do they follow the suggestions that have been made? Because we'll test anything they ask us to however they want. If they follow suggestions, it's going to be faster. And the other drawback or I guess consideration of how long it would take is getting materials. When you're doing prototyping, you usually have limited materials that are coming out of either a 3D print shop or a laser weld factory in Houston, or even just getting the cells themselves. The cell manufacturer, this may be a specific design for this battery that they don't have set up for their production run. So they have to go and do, a one-off run just for this prototype. The data we have stored is a collaborative chunk of data from other test labs that we work when we sit on UN subcommittees they'll call it round robin testing, where 7 or 8 labs globally will do the same test, and we all share that between labs. So when anyone needs to understand, hey, have you seen a test like this before? Yes, it's by experience. Then we consult, we'll share data, and that can give you guidance on designs, where is a start point, a baseline, if you will. Hey, will this type of container contain this battery? No, because we've seen this hundreds of times where it's always going to get out of that. But as a caveat, you may say, hey, this kind of container is overkill. You don't need a 400-pound, tank when you can just put it in sometimes as simple as a foil lined cardboard box. So having that shared data, it is all by experience. It's all real world. Simulations will get you close, but batteries like to behave however they want. So, I mean, just having the experience and the wealth of knowledge between labs, and we share everything and keep that, bank of data is very helpful.